Welcome to ChemDoodle Shorts. I'm Mary, your ChemDoodle Pro. Let's learn about differentiating basic geometric isomers using the cis-trans convention. Isomers are molecules with the same molecular formula but different structural or spatial arrangement of atoms. These differences influence the molecule's physical or chemical properties. There are two primary types of isomers: constitutional or structural isomers and stereoisomers. Constitutional isomers have the same molecular formula but different structures. Stereoisomers are molecules with the same atoms bonded in the same way, but the atoms are oriented differently. There are different types of stereoisomers, but we will focus on geometric or cis-trans isomers. Geometric isomers are stereoisomers, so they have the same atoms attached in the same way, but the atoms are arranged in space differently. They are diastereomers, which are molecules that are neither mirror images of each other nor superimposable. Cis-trans isomers are commonly seen in molecules with limited movement, particularly in alkenes with different substituents around the double bond, or cyclic compounds. Let's look first at alkenes. Alkenes have a double bond, which is rigid because of the pi bond between the carbon atoms, so rotation is restricted. The substituents cannot easily rotate and switch. Therefore, these molecules are different with differing properties. But how do we distinguish these molecules? They both have a 4-carbon backbone, a double bond beginning on carbon 2, and a methyl group on either double bonded carbon. They are both 2-butene. One method is to use the prefixes cis and trans. In Latin, cis means this side of, and trans means across or opposite. For the molecule on the left, the methyl groups are on the same side of the double bond, so this is cis-2-butene. For the molecule on the right, the methyl groups are on opposite sides of the double bond, so this is trans-2-butene. While alkenes are rigid because of the pi bond in the double bond, ring structures also have limited rotation because of their cyclic nature. Let's look at 1,2 dimethyl cyclohexane. In both isomers, there are 6 carbons in the alkyl ring with a methyl group on carbon 1 and carbon 2. Recall that in the wedge and dash projection, solid lines represent bonds in the plane of the screen. A wedge represents a bond coming out of the plane toward us. A dashed line represents a bond extending out of the plane, away from us. In the molecule on the left, the methyl group on carbon 1 is facing us, while the methyl group on carbon 2 is oriented away from us. The substituents are arranged in opposite directions, so this isomer is trans 1,2 dimethyl cyclohexane. In the molecule on the right, the methyl groups are both coming toward us on the same side. This isomer is cis 1,2 dimethyl cyclohexane. Remember to italicize the cis or trans to distinguish the prefix. Don't forget the hyphen too, which separates the prefix from the rest of the name. Geometric isomers, such as these, are molecules with the same atoms and bonds, but different spatial arrangement of atoms or groups relative to the restricted rotation about double bonds or ring structures. The cis-trans assignment is a useful method of differentiating geometric isomers with limited rotation, such as cyclic compounds and simple alkenes. Thanks for watching ChemDoodle Shorts.